We saw in section 7.1 that we can construct a confidence interval for the population mean mu under the case where we had normal data and that sigma, the population standard deviation, was known. We'll now talk about what happens if we do not have normal data or we do not know sigma and we relax those assumptions. So first of all, according to the central limit theorem, what we saw in chapter 5 was that even if we do not have normal data to start with, but maybe start with a skewed distribution, that x bar is still approximately normal if we have a large enough sample size. That's going to let us get rid of the condition that we have a normal population. If our sample size is big enough, everything will still be fine. Second of all, we have that value of sigma that we were assuming that we knew. What if we do not know that? We can always get the sample standard deviation, which we call S. And what we know is that if n is large enough, then S is going to be a good approximation for sigma. And so our confidence interval will still hold that we saw in 7.1 with S replaced there instead of the value of sigma. So we can still use the normal based confidence interval if our sample size is big enough. So what we're going to look at then is a confidence interval that looks like x bar plus or minus our z critical value that comes from the normal distribution times s, our sample standard deviation, divided by the square root of n. This is our large sample confidence interval for mu. The central limit theorem said we needed n of at least 30. Because we're also approximating sigma with s, we are going to bump up our sample size that we need and say we need that n is greater than 40. So that's going to be our condition for sample size to use this confidence interval formula. So here is the first example. We have a study done to investigate the lead levels of children whose parents worked in a factory where lead was used. We have a sample of 53 children. The sample mean for them was 31.85, and for those 53 children, the standard deviation was 4.54. So this S comes from the sample of 53. We want a 90% confidence interval for the mean lead level in the population of children. So first of all, notice our sample size of 53 is greater than 40. So this checks out for us to be able to use the formula that we're talking about here. If we're doing a 90% confidence interval, we looked up these z critical values already or made a list of them in that table. It will be 1.645 for a 90%. And we're given x bar and s right in the problem. So if we plug everything into this formula, we'll get 31.85 plus or minus 1.645 times 4.54 divided by the square root of 53. This is 31.85 plus or minus 1.026, giving us an interval from 30.824 to 32.876. So this is our 90% confidence interval for mu, where mu is the population mean lead level in these children.